against. And this is where we come in. So as you actually in the lighting, there has been a revolution going on where the level of control that is being used in lighting is significantly increasing, and almost all lighting upgrades that are now being performed in buildings include the rollout of a lighting control system. And as in many other industries, we are now moving the industry from wired controlled to wireless control, which means that every lighting fixture nowadays is getting equipped with a wireless chip anyway to perform the lighting control. And of course, we could use this very same radio chip as the infrastructure node for your IoT system. And this is exactly what we do. So we first of all, when your lighting is being upgraded, we use this infrastructure not just as a infrastructure for RTLS, but we really use this as a backbone network to enable a wide range of IoT functionalities in your building. So this includes localization, the topic of this conference, but we also do, for example, indoor navigation, where we use the radio chips in the lighting to provide indoor navigation capabilities to mobile phones. We do occupancy analytics, so we can see the occupancy rate of your building, which is especially now a very hot topic. And we use it to connect a whole range of battery-free sensors that are using energy harvesting technology. And we can connect them through the cloud, through our lighting, in a super energy efficient way, thereby eliminating the need to use batteries in a lot of sensors. So one of the main use of one of our largest success cases that where we applied this is the UMCU in Utrecht, which is a large academical hospital in the Netherlands, where we really provided the full service of making a building smart through the lighting. So we enabled their indoor navigation to have patients navigate to their position in a hospital. I think anyone that has visited a hospital knows how disorientating it can be and how hard it can be to find the exact room for your appointment. And this has a massive business benefit of reducing late show-ups at meetings, which is a huge cost to the hospital. We do occupancy analytics. Lots of meeting rooms and private offices are actually hardly ever used, and therefore we can achieve a huge reduction in occupancy in space requirements. And then, of course, we do asset tracking, where we track medical equipment. And what we there do is we deliver basically 4 main benefits. So first of all, we reduce the time spent by personnel to search for medical equipment. So on average, every member of active staff, so first line staff, is spending about 1 hour every shift looking for medical equipment. And by using the asset tracking technology, we can significantly reduce it. Then the second thing is we reduce the amount of medical equipment needed by about 10 to 15%. And this is because we know much better where the equipment is, and we can track the local storage levels in all the different storage rooms, and thereby actively manage this and reduce the stockpiling in local storage, and thereby reducing the amount of medical equipment is needed. And the third thing we do is we deliver compliance. So medical equipment needs to be maintained and on a yearly cycle or a timely cycle, and we make sure that every piece of equipment that is due for maintenance can actually be found. Then we optimize climate control by deploying sensors throughout the building that help optimize and monitor climate, which especially in hospital is extremely important as it's directly related to patient recovery. And we support battery and free and wireless call buttons that can be placed for a variety of services. And so, for example, send me a bed, please clean this room. And this information is then directly linked to the cloud environment of the hospital. And then, of course, we provide lighting control, but that is almost a side effect of the services that we provide. Now, the interesting thing is that we do not provide this as a vertically integrated solution. Instead, what we do is we work together with a wide range of partners. So our network gives the backbone, and we have partners that build different applications on top of this, either by mobile phone or cloud applications. And we have sensor manufacturers that produce all kinds of sensors and tags that then connect to our backbone infrastructure, and we send that data to the connected cloud and apps that are connected to our solution. And this allows us to really use the best of breed for every application. Because as you can imagine, there are companies specialized in indoor navigations, in asset tracking, in building control, building automation, and each of them has their own specialty. And people have specialties in delivering sensors or in the clouds and apps. And we believe that it's crucial that you utilize an ecosystem to deliver this. Now, if you look at what we track, I mean, we really track a wide range of things. So that range from all kinds of medical equipment to personnel to wheelchairs and personal goods. And so these are some of the key asset tracking applications that we built, including seeing the stock levels, so we can see of every local stock, every local storage room, the current stock levels, and we can intervene in that if they're getting low, or we can identify stock levels that are overstocked and reduce stock at that place, and thereby reducing the amount of unnecessary waste. Now, one thing that we often get as a question from people outside of the lighting industry, they say, well, then this is probably only useful for new builds because I already have lighting. But actually what we're seeing, and I think even if you're not in the lighting industry, you will have noticed that there are that there's huge amounts of energy saving being deployed. And lighting is a key element of this. So we're seeing a huge rush in hospitals and other buildings across the planet to deploy energy saving solutions, including retrofitting the lighting.
Excellent.
So that was it.
Excellent, Bastian. Thanks. Thank you very much. So what we learned from you is that we also see a versatility of ecosystems arising on the field level. But what is important is the openness to these platforms that Jörg was referring to. So that was a very good example from the hospital space. Now, I would like to hand over to Sakshi Hotwani from Diconex. And Sakshi is again one of the representatives of the young and wild, with the innovations coming fast and maybe also game-changing. I'm very curious on seeing how Sakshi is doing RTLS with a 3D visualization tool and digital twin technology. So it is great to learn from you, Sakshi, how you do it, and maybe we have another technology to put on Jörg's presentation for the next time. Thanks a lot. Floor is yours.
Okay, I would just start with the presentation there. Good morning, everyone, and thank you, Thomas. So I will be presenting the digital twin as a localization technology. Here it's a localization technology, and it will be, and I'll be talking about its applied use in the facility management. So while my colleagues so far have been emphasizing on the technical processes of localization, I would take it further and demonstrate a case study with some new tools such as a video, and I would demonstrate a project which was done for some cases. First of all, in this digital age, networking between people and systems is the key. So this digital twinning technology is is optimized for like digital connected factory flooring, such as transmission of data from like a production machinery to a conveyor belt. And that is in real time. And this is in case, of course, achieved through this is of course in case achieved through sensors. So sensors are connected to digital twin. What you can see here is it's a facility management which we had done for a building in Hamburg. It's called Elbphilharmonie, and this is a screenshot from the digital twin, the DIGA twin as we call it. And here you see on the screen there are multiple POEs or point of informations, and this digital twin acts as a platform for easy linking of external data sources. Well, all the data which is there is also about the machinery and about the real status can be inserted manually. It can also be connected with sensors like this, like I have here. So this is one small sensor which is from a partner called Zigpus. So I will just demonstrate the whole process through a little video that was done for another project. This is a screenshot again from the data. So here, my colleagues are trying to navigate to each other using the sensors. So one colleague has a sensor on him, and the other could also be on a machinery, for example. And they're just trying to use the digital twin where it shows the real-time tracking. Yeah, and so this is one application where one person or one point of information can be accessed to with another just with the communication between sensors. And this is an application which was implemented in a project which is in FIGA. This is a facility which is in Großhering in Germany, and I would just like to demonstrate the same technology. So this is a video screen grab from the digital twin. On the right that you see are the tasks which are raised and the machinery which are all there. And using that, we can just navigate to there with the sensor points. This is a particular like a job status window where you can name what machinery is there, what is the due date, the priority of how urgent the issue is. You can assign and also write the description. And lastly, there's a status option where we can review the status, update as done, as planned. So this is how the sensing technology is integrated with digital twin. So here the digital twin actually is where virtual modeling meets IoT. In this case, it's a facility, and it's real size. It can be scaled, and it's navigable as easy as Google Street View. With the digital twin, operators have a 3D interactive model which is superimposed with real-time data which is coming from sensors, and visual clues are provided. For example, if you want to know the health of the machinery, you could just have already preset standards for data analysis that could be color-coded or numeric metrics, and that would probably state the health of the machinery way before it has gone to the critical breaking point. So like there are in machinery that I showed in the Elbphilharmonie, if you already have a temperature coding of red, yellow, and green, that would already indicate that if it's close to the breaking point or to the maximum heating point of a HVAC duct, it's probably best to kind of cool it down or stop it from further breaking. So this is how it could be used. The data integration of the digital twin is done through the IoT systems. Well, it's a three-step process of integrating data from sensors to the digital twin. First of all, we have to identify the technology, such as a 3D modeling tool, or it could be a scanning. It could be done through total station surveys or terrestrial scanning. Secondly, it's the data integration aspect, which is if whatever data is coming from sensors is already captured into a cloud and could be superimposed into the digital twin for easy understanding. Lastly, it's a data analysis. Like I said, there has to be some preset metrics for the data analysis, such as temperature coding or marks or like status checks and so on. So yeah, this is one use case of the digital twin as a localization technology. It could be used real time in facilities, but they also have extended applications in large scale infrastructures, building construction sites, and so on. Thank you. If you have any questions, you can please put it in my chat box, or in case the time is limited, you can also feel free to write an email to me on my address. Thank you.
So, thank you very much, Sakshi. Thank you very much, all panelists. And when I have one learning from moderating a virtual session, it's much more difficult than in a room to keep the timeline as planned on the schedule. It's really a challenge, but I think the presentations that we had were super interesting, and I hope the audience is appreciating that we have given everybody the time to present his use case. So that's why I would like to keep the question and answer pretty short and pretty generic. So Jörg, the first question that comes in is a bit on the, let's say, how to combine, or which devices or business systems will be location enabled in the future. So what is the versatility of technologies you have to handle when you are delivering a platform solution to the customers? So what is next, in your opinion?
So I think the location enablement, as I do see it, will certainly happen with ERP systems like SAP. I think that's going to come. I'm pretty sure that MES vendors will do the same. So I was involved in some of these dialogues that they are looking for that data. You won't see the location platform as such. So I think the way forward from a technical point of view is more a white labeling approach. I think the same is true for warehouse management systems or hospital information systems. Wherever you need location and you have a leading system, people tend to use that piece of software in a white labeling mode. That's what I do foresee from a business system point of view as an evolutionary approach.
Thank you, Jörg, and this is a great perspective for our end users, and a big work ahead of all of us which work in the ecosystems and the different layers. Martin, the question for you on the versatility of technologies. So you're coming from the telecom industry, is pretty much bound to, let's say, 5 years ago it was about selling SIM cards, and now you have been evolving tremendously into other technologies. How do you see the further adoption of, or the further evolution of telecom companies or telecom operators in the RTLS world, in the stacks that you are presented?
Yeah, very good question. I think this is a very important point, because several years ago it was, like you mentioned, most of the business was to sell SIM cards or stuff like that. But we see that just with different requirements, we also need to adopt. So every company which is actually available and active in the field of IoT needs to have also then different solutions for that. So we see, for instance, in our projects very often that it depends highly on the use case and on the branch where we actually have our customers. So I think SIM card is still an important part in the whole IoT stack, because if you think about outdoor tracking cases, or even tracking cases where you have localization on a small area, but you need kind of gateways, or you need kind of this connection actually to the platform, then I think SIM cards will still play a key role. But at the same time, you need to be aware that you combine with other technologies. This could be RFID, this could be Bluetooth Low Energy, or this could even be other technologies, which actually bring you then also the benefits of having more accuracy indoor and on let's say on smaller areas where you will be never that precise with pure SIM cards or a GPS module indoor, for instance. So I think, and so I see the future like that these technologies need to even more combined than it's already now, to be at the end of the day possible to deliver the end-to-end solution then for the customer. Yeah.
Thanks a lot, Martin. Thanks a lot. Sakshi, the question that we have for you is around infrastructure. So you said so more or less the question, you are implementing IoT technologies in the facility. So somebody must go there, somebody must do something. Could you elaborate a bit on how this infrastructure deployment, what effort in your particular use case that you presented, Philharmony, for example, what that meant to the facility manager on the planning side as well as on the implementation side?
Thank you so much for the question. It's very interesting. So, like you said, to access the infrastructure is must, but only limited, only for the people who are going to survey it to be translated into a digital twin. So once the information and a real photogrammetric, like a real navigable 3D model is established, which is called the twin. Once it is established, there is no more need for the facility manager to be on ground, or for that matter, any building operator or an owner or an investor to see what is the real status of the building. They can happily and they can easily navigate it and understand the status on the twin. It is due to many features, which I showed some of them, which is like the task updation, which is the defect management, and there are so many more features such as remote planning, due to which there is not much need for the stakeholders involved to be present on ground. This also applies in a facility, as in if there are shifts, 3 shifts or 2 shifts, the person who left the work at some stage does not have to necessarily communicate with the person who's going to come and occupy his place a second. So it could be just updated on the twin, and that could be taken forward from there. Right? So the presence on ground is only limited to the point that once the twin is ready, up and ready, and it's functioning, then there is no more need. But the twin also needs to be updated if there are considerable changes on ground, like if a particular part of the building or a facility has been changed considerably, if the machinery interaction has been changed. Let's say if there is a production plant and it's communicating data with the conveyor belt, and if by any chance the whole data transmission is interrupted, that needs to be scanned again and re-put or instated into the digital twin. But as soon as that is functioning fine, there is no more need.
Great exploration. Thanks a lot. So you're reducing the second visits, which usually kill the business case in IoT. Thanks a lot. Thanks to all panelists, and thanks to Jörg for this impressive keynote. So we are coming to an end, and I would like to invite all the audience to contact the EU Tech people, be it me as an advocate or Alessandro or Jörg Schiller, on getting more information. And we are also planning to work on a white paper on bringing a bit more light into this very versatile industry. I would say the title could be Flattening the Stack in RTLS in order to get all technologies sorted and make a bit more guidance for the end user on what he decides or he or she decides about. I would like to hand over to Jörg Tuchen. Is he online? For thanking the panelists and closing the meeting.
I think, Thomas, it's Alessandro. I think that no, I cannot see your.
Okay.
But if you want, I can thank you, our panels, and
yes,
and the 3 certificates. Yeah. Okay.
Yes, please, Alessandro, in your role as Secretary General of the IoT Council, it would be great if you take some closing words, and thank you to all. Thank you to the audience.
Okay, thank you very much. So thank you. We would like to thank you, all our participants today, for this very interesting speech that we had. And so we'll be very happy if we can stay in touch with you and to look after our future events, which we will have for sure, also on these particular topics. Finally, to close it, I mean, as you probably noticed, as the European Technology Chamber, we are very much into sustainability. And in order to thank you, our panels, for their efforts and for the time that they used to explain these very interesting topics to us about IoT and localization technologies in indoor position systems, we would like to give them a tree certificate. This certificate is about the fact that we will plant 10 trees for each one in Africa at our cost, of course, and this is as a present and for them. So this is the tree certificate for your course week. So thank you so much, Jörg, for your intervention.
Okay.
Thanks. Thank you very much, Martin, as well. This is your certificate for the 10 trees we're going to plant for you. And so thank you so much for your intervention too. Also, we have the 10 trees for Bastian. So thank you, Bastian, for your great intervention. It was really very interesting to hear from you. And finally, for Sakshi, the 10 trees for you. Thanks so much, Sakshi, for your intervention as well.
Thank you.
So I would like to thank you, all our participants in our webinar, and please feel free to post your questions, and yeah, see you next time.
Thank you very much.
Thank you. Have a good day.
Bye bye, everybody.
Thank you very much.
Enjoy. Bye bye.
Bye.
Okay, so thank you so much for everybody. So I hope that you had. Oh, hello, Jörg. So we couldn't see you, unfortunately. So I've done the 3 certificates already.
You have done it already?
Yeah. We've done already because.
Oh, I'm sorry for that. Okay.
Yeah, and so we completed. It's finished. I mean, sometimes I struggle to upgrade people from when you enter. Did you enter as a panel?
Okay. Okay. Has said the truth and want me to.
Also, we would like to hear from you, Jörg.
Very quickly.
Yeah. Please.
Yeah. But I think that's your presentation. Sorry for that.
No. If you want to say something else about.
Yeah, that's a little gesture of our, and for me as chair of the Climate Action Partnership and the managing director of GoBlue Now, which is a climate consulting company, it's always, special to climate and climate protection, CO2, and help a little bit to prevent the global warming to even further accelerate. And I just, if you have interest in learning more about our tree planting program in Africa, which EUTech has, and or about our approach, how we support other companies in becoming climate neutral over time, until a degree or until a target which is in line with the 1.5 degree promised in Paris in 2015, please reach out to me, contact me. I'm more than happy to engage into any kind of dialogue, to answer any kind of question. So enjoy your certificates and enjoy your trees. There are 10 trees planted for each of you in Africa. And from my side also, one last time, thank you very much for your participation here, your presentations and discussions. and have a great upcoming weekend.
Thank you. Likewise.
Thank you, Igor, as well. Bye-bye, everybody.
Bye. Thank you.
Bye.
Bye.
Bye-bye.